This call is now being recorded.
Okay, Assalamualaikum. In this video, I will explain you on how to complete your Lab 1 partially, meaning that I will explain you the first half of Lab 1. Okay, so this here is the Lab 1 lab sheet, and you need to fill in all those. You can use the same lab sheet and do some modifications and adjustments and submit it as your lab report later, okay? Or you can also just use the first page as your front page, and then inside the content, you can do according to your preference, okay? And for lab 1, as you can see here, there are 3 learning outcomes listed that we instructors expect you to achieve. Students should be able to apply equations to calculate electrical force, electrical field, potential energy, and electrical potential. You can see that there are 4 equations that you have to know the right equation in order for you to use the equation and find those values. And then you are required to simulate and verify the simulation results obtained. This is for electrical forces, F, and also analyze the electrical field, E, and also electrical potential, V, around a point charge, Q, as well as force and potential energy for multiple charges using appropriate simulation tools and equations. So for the first part, I will concentrate on how to calculate electrical force first, okay? So you need to click on the link given to get to the simulation page or to the simulation package. You can use your browser. You do not need to download any application. Just use it direct from the browser. Go to simulation link 1, and then before that you need to actually read all this, but this is actually the same thing that I have mentioned to you yesterday during the first class. I will explain more during the second lecture. Here, just observe that there are 3 kind of items or 3 kind of components exist in an atom. Okay, so there are 3 items, and those are electron, proton, and neutron. So if you see here, you can see that between these 3 components or 3 items, which has the most heaviest mass? If you can see here, there are 2 items that has the same mass and they are heavier compared to the other one. And those are proton and also neutron. Electron has the lightest mass, meaning this explains why in atomic movement or motions, electrons that are moving from one body to another body or etc. You don't see or you don't explain or in the theory, we don't say protons are moving, neutrons are moving. No. So usually or conventionally, electrons are moving instead of those 2, proton and neutron. Okay, so when an electron leaves a body, a mass, a body, the body is said to be positively charged because it is losing one electron, one negative charge, right? And when a body receiving more electrons from outside, so we can say that the body is actually negatively charged because you are receiving more negative charges in the body, making the net charges is more negative. It's more negative. Okay. So, and how to calculate force? And this here explain to you the equation. Okay. So, basically, force the electrical force, the amount of force that is experienced by a charge, an electric and a negative charge or a positive charge can be calculated by using this equation too. And there are constants involved and also other parameters as well. The constant here introduced here is Ke or simply K, and that is Coulomb's constant, and the value is 8.9875 times 10 to the power of 9. You can also simplify there are also calculations that simplify this K 8.9875 to the nearest decimal value, that is 9.0 times 10 to the power of 9. Or some even calculate or use 8.99 times 10 to the power of 9. So before you attempt to answer questions to calculate electrical forces, it is much easier, or will be very helpful to you and also the evaluator, the assessor of your answer script, that you tell them what is the value of K that is used to calculate your electrical force. So no harm in using this value, 8.9875 times 10 to the power of 9, or as simple as 9 times 10 to the power of 9 is also acceptable. R is actually the distance between the two charges, and it must be in meter. If the value given is in other form, maybe they give you in centimeter, or maybe millimeter, kilometer, maybe. So you have to change it to meter. Okay. And Q is actually the charge, the electric charge. Magnitude meaning how much is the charge value of the charge. See, because one electrical charge carries a charge value, and those charge value, the unit is C or Coulomb. So you need to identify what is the value. And from the table before, an electron, a value of an electron is negative 1.602 times 10 to the power of negative 19. So that is one electron value. So meaning if you have a charge Q, it can have a multiple of electrons, multiple of protons, and so on. So we will see those later when you go deeper into the first part of this lab one. Okay, so this is electrical field. Electrical field will be used in the second portion. So I'm gonna first go to the first portion first, that is to calculate electrical force. So experiment 1, procedure. To determine electrical forces between two charges. So you have two charges and you want to calculate the electrical force that exists between these two charges. And bear in mind that the electrical forces can be a repulsion or an attraction. They can be attracted or they can be repelling from each other depending on the polarity of the charge. As I mentioned before, similar polarity or similar signs of charges, meaning positive charge, or negative charge, they will repel. If one of the charges has different polarity, meaning positive, you have two charges, one is positive and the other one is negative. Therefore, the kind of electrical forces that exist between these two different charges is attraction. They will be attracted to each other. So go step by step. Open simulation link 1. Set up experiment according to figure 1. So figure 1 is given to you. So you need to set up the experiment just like this. Okay. So what's next? Number 2, use the same charges value and the given value is 2 UC. So usually we don't say 2 UC. That is actually not U, but that is actually to represent micro. 2 micro. So what does a micro means? A micro means 10 to the power of negative 6. Okay. So the charge value is Q1, Q2. Q1 is equal to Q2 and is equal to 2 times 10 to the power of negative 9. To the power of negative 6. Okay. So there are tables given to you. Table 1 and table 2. So you need to go to those tables and fill them up. Let's go to the first line here. Okay. So just now we know that to calculate, let me explain a bit on how to calculate electrical force. So let's say you have one positive charge Q1 and another electrical charge Q2, also a positive charge, and those charges are separated by a distance r. And this r has to be in meter. When those two electrical charges meet or in this position, there are electrical force exists, and those electrical force will be a repulsion. They will be repelling each other, meaning for Q1 will move in this direction. Okay, why? Because the Q1 is trying to move away from Q2 because they repel each other. So this force here, you will call it as F12, meaning force on 1 due to Q2. Force on Q1 due to Q2. Okay. And the second one, Q2 is also experiencing an electrical force because Q1 is near to Q2 with the distance r, right? So Q2 here will also try to move away from Q1, and this can be represented by a force. We call it as force. Can you guess? If just now you are measuring the force on Q1 and you call it as F1. So if you are measuring the force on Q2, you are actually measuring the force on 2. To differentiate or to identify, to noting which this force exists due to which Q. So you need to say F force on Q2 due to Q1, F21, and the other one was F12. So to calculate both, actually you are using the same equation. So F, just now, you know that F is equals to KQ1 Q2 over R squared. So you take Q1, find the absolute value. Q2, use the absolute value as well, define with R squared. So if you want to find F12, you take Q1, and since Q1 is given by Q micro C just now, right? Both have the same positive C value. So Q1 times Q2, also in positive value, divide, I left out Q. Divide with R in meter squared. And that's it. The same thing, the same equation also for you to calculate 2-1. Because in calculating 2-1, you are also have the same value of Q1 and Q2, and also the same value of R. And that's why we say those two are equal to each other. So we can say therefore F12 is equals to F21, except that F21 here has a direction to the right, and F12 has a direction to the left. This is only true if you are only talking about the magnitude, the value of the force. But when you are talking about the direction of F12 is not equal to the direction of F21, because F21 has a direction of how do you measure the direction? You need to use like for example, this is the force, right? So let me redraw. So this is the line that you want to, this is as your basis lah, to measure the angle or the direction of the vector. So if your vector is in this direction, I cannot remember how to change the value, the colors. Okay, so let's say I want to use this as my, can you see that? No, you cannot see that. Okay, never mind. I'm gonna draw it like this. So this is F21. This is the force F21. To calculate the direction, you need to start from this basis line here and go to what do you say? Anti-clockwise direction. That way. So from here is 0. So when you move up, you will calculate the degree. So if your F21 is that direction, meaning the degree is 0 degree. What if you are measuring the direction for F12? So for F12, let's draw the basis, the base line. This is the baseline, and your vector is the other way around. So you need to start calculating. Let's say the pivot point is here. So you measure the angle from 0 to how much is the angle? It's 180. So the direction or the angle of F this is what is the vector just now? F12. The direction of the vector or the force of F12 is 180. Okay, so that's why we say when you talk about magnitude, yes, F12 is equals to F21. However, when you talk about direction, they are not the same. The first force F21 has a direction of 0 degree, meaning it goes to the right. And the second force F12 has a direction of 180 degree, and meaning the force is moving to the left. Okay, let's move on. You have to fill in this table 1 and table 1.1. You need to do the simulation setup and then observe what is the value. For example, here, I will show you only one example and then later you will try to do it on your own. Okay, for this table 1, the instruction requests you to use Q1, Q2 values as shown there. And then the distance is varying from 2 centimeter until 10 centimeter. For the first distance, let's do that. So let's go to the simulation. And from this simulation, you can move around the what you call this, the ruler. So make sure you want that 2 centimeter, okay? So this charge, the second charge, the second charge or the first charge can be moved around. So let's say you want to fix one of them. Let's say I want to fix Q2 here. And then, I want to fix Q2 there. And then I move the ruler here, meaning, Q1 there. And I move the ruler to Q1. And that is where I will measure R. Just now, your R need to be 2 centimeter here. Need to be 2 centimeter. So you will go to your simulation and set the Q2 to be apart or with a distance of 2 centimeter from Q1. So that is what is meant by that instruction just now. So how do you measure, where does it show you the force? Here, 89.876. And you can see that the magnitude are just the same. Force on Q2 by 1 is the same as force on Q1 by Q2. Okay? So you can also try to use this scientific notation or not, depending on your preference. You can also not to use, you can also use them. Okay, back to here. So you need to fill in these tables, okay? Please use the Word document and edit in Word file, okay? So you have to key in the distance. The distance is 2. Now you need to write it in meters. So meaning 2 centimeter, meaning 2 times 10 to the power of negative 2 meter. The electrical force that you get just now was, what was the value? 89876. 89876. So 89876 Newton. Please confirm that. Yes, 89.876 Newton. So you are okay with that? Is the charges repel or attract? So you know both are positive charges, meaning it has to repel. However, you may also go to the simulation just now and observe. Can I make this bigger? No, I cannot. So you can observe that those two small people there, those two small person there is actually holding or maybe stopping Q1. In this case, you can see that Q1, the fella is actually stopping Q1 from moving towards him. And the the right person here is also stopping Q2 from moving to him. So the force that experienced by these two charges are actually repelling each other. So that's what we meant. So let's continue to table 1.1. So let's go to the instruction just now. Sorry. Oh, wrong document. Okay. Let's go to the lab sheet again. And okay, let's start at number 3 here. Make another table 1.1, and answer the following question. Calculate the value of K used in this simulation and fill up in column 5. Okay, so meaning this table 1.1 in column 5 here, they need you to actually determine what is the value K used in the simulation. Because just now I mentioned to you that the value of K you can choose, right? You can choose it to be 8.99 to the power of 9 or even 9 to the power of 10.9. So I want to confirm, I need you to confirm what value does the simulation use in the simulation just now, the electrical force that you obtained just now. So you need to rearrange, isn't it? How do you rearrange? The equation just now was F equals to K Q1 Q2 over R squared, right? And now you need to find what is K. So you need to do some arrangements. Bring R squared to F to the other side, and you get F R squared equals K Q1 Q2. And you can find K by actually multiplying F with R squared and divide with Q1 and Q2. So the value that you get here will be used in column 5. Okay, put it here. So when you have that value, try to recalculate the force using this equation back. Put in what the value that you calculate just now inside this equation 2 just now, right? Equation 2. And then recalculate the force. That will you get the same value as column 1? You should get. Okay, do not simplify or try to reduce any of the numbers that you get here. Take those numbers, calculate F, and you should get the same value with the simulation result. And then I want you to decide your own value of K. You can take this one as suggested by the lab sheet, 8.9, or you can also try to use 9 instead, up to you, or maybe 8.99. Let's say you decide you want to use this, the same value, 8.9. So you plug the value here, 8.9 10 to the power of 9. And this goes the same for all the lines. And then calculate this force according to the value that you have determined in column 7. And as expected, you as an engineering student, you should know that whenever you use different values with the different decimal points, you will get a different value, a different answer. So you can anticipate that the values that you get here in 6 is different from what you get in 8. Okay, so the question keep asking you whether that is okay or not. So please to justify on that. Okay, so I guess I'm going to stop here and I will continue. Please find another video on Lab 1, and that is to explain the electrical field using the second link of the simulation, and as given here, here 2.2. Okay, thank you very much.